Welcome to the Computer Network series. Today we are learning contention-based access protocols, or otherwise the listen before talk or the random access protocols. I appreciate and request you to see my previous video on Pure ALOHA before getting into this video. We have been discussing Pure ALOHA the previous video. This video is completely focusing on Slotted ALOHA. In Pure ALOHA, what was the biggest problem? Frequent collisions and low efficiency. Why? Because stations could transmit at any random instant. So what is the bright idea? What if we restrict stations so they are only allowed to transmit at fixed time? Brilliant, right? So this idea led to the creation of Slotted ALOHA. Slotted ALOHA is a contention-based protocol in which time is divided into equal-sized slots, and a station is allowed to transmit only at the beginning of this time slot. Why go through the trouble of making slots? In Pure ALOHA, stations transmit anytime, creating a large vulnerable period of 2 times the frame time, 2t, where any partial overlap causes a crash, collision. In Slotted ALOHA, stations must wait for the start of the slot. Collisions only happen if two stations choose the exact same slot, cutting the vulnerable period right down to t. So here the vulnerable time is t, whereas in Pure ALOHA, the vulnerable time is 2t. Fine. Look at the picture. This clearly shows that Slotted ALOHA is quite better when compared to Pure ALOHA. Look at Pure ALOHA, the unsynchronized example. Stations transmit anytime, creating a large vulnerable period of 2t. In Slotted ALOHA, stations wait for the start of the slot. Collisions might happen, yes, but when? Only if two stations choose the exact same slot, cutting the vulnerable period from 2t to t. Let's discuss the working of Slotted ALOHA. Walking through how Slotted ALOHA works step by step, this is how. Step 1. Time is divided into equal slots. Step 2. A station with data waits until the very next slot begins. Step 3. It transmits right at the beginning of that slot. Step 4. If only one station transmits, it's a success. If multiple stations transmit in the same slot, it's a collision. Step 5. After a collision, each station waits for a random number of slots before trying to send again. Fine. So the flowchart at the right maps out the journey of the frame. A frame gets ready, waits for the next slot, and transmits. Next, it waits for an acknowledgement. If the acknowledgement is received, great. It's a success and the frame is done. If no acknowledgements arrived because a collision would have occurred, the system flags a collision, tells the station to wait for a random number of slots, and loops right back to try again. Fine. Let's look at a quick example with 3 stations, namely A, B, and C. Slot 1. Only station A transmits. What is the result? Successful. Slot 2. Both station B and C try to transmit at the same time. What's the result? Collision. Both back off and wait for random slots. Slot 3. Only C retransmits this time. Yes, result is successful. Fine. Talking about the vulnerable time comparisons, let's look very closely at this vulnerable time. If frame transmission time is t, Pure ALOHA gives you a vulnerable window of 2t. Please check the video of Pure ALOHA to understand why it is 2t. But because Slotted ALOHA forces transmissions to start strictly at slot boundaries, another station can only cause a collision if it targets that exact same slot. This means Slotted ALOHA drops the vulnerable time to just t, reducing the risk window by a massive 50%. Fine. Now how do we measure performance? We use throughput, which is calculated as S is equal to G e to the power minus G, where S is your throughput and G is the offered load. The absolute maximum throughput happens when G is equal to 1, which gives us S is equal to e to the power minus 1 or roughly 0.368. So this means that the maximum efficiency of slotted ALOHA peaks at 36.8%. When compared to pure ALOHA, it is much better. Like all protocols, Slotted ALOHA has good and bad sides. Coming to the advantages, fewer collisions than Pure ALOHA, better channel utilization, higher throughput, overall higher throughput, and it is very simple to implement. Talking about the drawbacks, it requires strict time synchronization across all stations. Ideal slots can waste valuable bandwidth, and collisions can still happen if two stations pick the same slot. Fine, where do we use this in the real world? Slotted ALOHA is commonly found in satellite communications, RFID systems, early wireless networks, and various research or educational network setups. To wrap up things, let's compare both side by side. Transmission time, Pure ALOHA happens anytime. Slotted ALOHA transmission happens only at slot boundaries. Synchronization, Pure ALOHA doesn't need it, Slotted ALOHA requires it. Vulnerable time, Pure ALOHA 2T, Slotted ALOHA vulnerable time is T. Maximum throughput, Pure ALOHA makes about 18.4%, whereas Slotted ALOHA makes about 36.8%. Collision probability and efficiency, Pure ALOHA has high collision risk and low efficiency, whereas Slotted ALOHA has lower collision risk and higher efficiency. Any doubts? Post it in the comment section. Thank you. Happy learning.